Okay, so let's start with a really brief review of where we've gotten to. So we started off with this notion that maybe categorization would be the basic cognitive process in terms of which we would analyze, formalize, and mechanize all the other cognitive processes. We looked at basically 4 theories. So we looked at so 2 theories of categorization and 2 theories of concepts. Categorization was supposed to be like how you understand the world, and concepts are supposed to be like mental entities that live in your head. We talked about similarity, resemblance. By the way, if you Google search similarity, this is one of the first things that shows up. So the similarity theory said we categorize things in terms of their surface level similarity or resemblance. Similarity is a matter of sharing features. And we saw a bunch of problems with this, like Goodman's problem of how everything has an infinite number of features in common with anything else. We saw some serious problems about how do you figure out which features are relevant. It seems like we need to order our features that we're comparing in terms of their relevance. And we discovered that that was a really hard to formalize property. We talked about the classical theory of concepts and found that although it solved the problem of relevance, it did it in a really blunt way. So it solved the problem of relevance by pre-specifying which are the relevant features in a short list of necessary and sufficient conditions. But then we found that our concepts just really don't seem to work that way, right? Our concepts just don't seem to come with neat little packages of necessary and sufficient conditions. We moved on to the prototype theory. Concepts are defined by prototypes because the classical theory had this problem where it was drawing too crisp boundaries around concepts, right? Concepts seem to have, in the classical theory, really clear boundaries where something is or isn't in the category, and you can always tell, and everything that's in the category is equally good, everything that's out of the category is equally bad, and we just don't reason like that for tons of parts of our life. We just simply don't reason that way. So the prototype theory tried to resolve that by having fuzzy boundaries, fuzzy sort of like edges around your concept where there was a large area where it's unclear whether you're in the category or not in the category. So that was good. But we found that the prototype theory suffered many of the same faults as the resemblance theory. We need this stuff about which features are relevant, and we explored in the prototype theory some of the ways in which what's relevant changes across contexts. So you can't just sort of like lay out what's going to be relevant to a concept. You have to ask the concept in a context. And that seemed worrying, right? Because then you haven't got sort of simple, neat little concepts. You've got a concept for, remember the stuff about typical beverage for a trucker, typical beverage for a secretary. And then we worried a little bit about how many concepts you need to have to make that work, because there's just a lot of different contexts that you're reasoning across. We also saw this stuff about unstable typicality gradients, right? So people would make different judgments of how typical something is of a category across different contexts. Again, it seemed like there's just not enough in the theory to explain how we do that. These prototypes were represented just as lists of unstructured lists of features, just like the similarity theory had unstructured lists of features. And so finally, last time we talked about the microtheory. The microtheory was supposed to be an advance on this because instead of having unstructured lists of features, our concepts perhaps are more like scientific theories. That is, they are structure, internal structure. The parts of the concept are related to each other in important ways. And they're related in just the same way as parts of a scientific theory are related, right? They're moving parts that all work together to generate predictions and explanation and understanding, which is, of course, what you want your concepts to do. If you have a concept of something, you want it to help you understand that thing, make predictions about it, and help to explain it. So microtheory seemed to be taking much more seriously the way we use our concepts, and it had some nice features like scientific theories are context sensitive in the way that concepts are. But of course, we ran into this ugly little homunculus at the heart of the theory, which is that you need to be able to reason in order to explain and theorize. And if you've got reasoning at the heart of your theory of reasoning, then you've done a circular explanation. So that was the problem with microtheory. Again, not that it's wrong, not that it's incorrect in any important sense, but that it's not an analysis of categorization. and then we despaired and cried and gave up, and then we said we'd move on to memorization. Or memory. Just briefly before we do that, there's a couple of big themes that I'd like to pull out of this that are going to be important again in memory and then important again in problem solving when we move on to that on Thursday. They're sort of related themes. The first one is what we call the Finitary Predicament. So this is the rather unfortunate state that we all find ourselves in of being really small in a really big universe. The universe is just way, way bigger than we are. I'm not even talking about, I've got a picture of the galaxy up here, but I'm not even talking about the galaxy. I'm talking about like the amount of information that's available to you on a daily basis so hilariously and vastly outstrips our ability to take in and process that information that we have to be selective, right? So somehow we have to deal with this problem of having chronically like not enough processing power, not enough memory, not enough time to deal with all of the information that we potentially have available. So think back to the Goodman's problem for similarity, right? We said two things share an infinitely large number of features, like my right shoe and my water bottle are both smaller than Venus, but why doesn't that strike you? Why doesn't that jump out at you when you're thinking about categorizing the world? Because that's not relevant, right? So somehow what we're doing is like focusing in on just a tiny, tiny, tiny fraction of the available information and sort of like relations between information. And we have to do this because we're tiny. We are tiny little primates running around on a thin crust of Earth on a tiny, tiny little planet. And so what we need, if we're going to analyze how we do cognition, is a theory that can explain how we do that. How we, as finite agents, right, deal with the unremitting complexity of the world. So if your theory involves, for example, having an infinite list in your head or doing an infinite number of computations, that theory's got to be wrong, right? Okay, and then that broad theme, which is going to sort of plagued us throughout categorization, come up again in memory, it'll come up again in problem solving, is kind of deeply related to this question of relevance. So classical theory, for example, assumed that relevance could be pre-specified, right? You could say in advance what's relevant to something being a bird or being a human, and that just doesn't seem to be possible. Why do we have to deal with relevance? Why do we care about relevance? If you were God and had infinite computational capacity, you wouldn't have to sort the world into relevant and irrelevant, right? You could just pay attention to everything. But we're not gods. We have to be selective. Because we're in the finitary predicament, we have to be selective and pay attention to, home in on, just those features of our world which are relevant. And it seems really, really difficult to say in advance what's going to be relevant. So again, that's why classical theory doesn't work, because it's a theory that assumes that you can say in advance what's relevant to a concept. Similarity and prototype theories acknowledge that relevance is part of our categorization practices. They built it right into their formalisms. They had a little f that says how relevant, a function that says how relevant given features are. But then we noticed that that's a homunculus. That's a very intelligent thing that you do, working out what's relevant and what's not relevant, and therefore they hadn't fully formalized their theories. Yeah?
Does this also play into like saliency with respect to that?
Yeah, so salience is almost a synonym for relevance. Salience usually has a more perceptual quality though, so something is salient if it like jumps out at you and captures your attention, whereas relevance is something can be relevant to you but not salient. If you fail to notice what's important, it can be, it's important that you notice this, but you didn't jump out at you.
If I'm making an inference for like a theoretical feature that I'm a scientist and know, that's less perceptual and more functional.
Yeah.
This be more with respect to that than perceptual?
It's not, there's not really regimented. They're basically the same word, but salience tends to get used more in the perceptual realm. You could talk about theoretical salience, you could talk about perceptual relevance. They're more or less interchangeable. In fact, lots of things get smuggled into, like lots of words mean relevance, importance, centrality, salience. These are different ways of saying that something is important. So we know that we need to track what's in. Because we're in the finitary predicament, we know we need to be tracking what's important. You have to only pay attention to the important stuff, or you need to allot your attention to differentially to the important stuff and not get bogged down by things like, hey, your shoe and that bottle are both smaller than Venus, right? And prototype theory, similarity theory both acknowledge this. They included it in their formalism, but they didn't formalize it. And that was another homunculus in their theory. Microtheory invoked our ability to make and understand explanations, but that seems to involve the ability to judge relevance as well. Yeah?
Does this also play into kind of the microtheory as well as just theory-based approach, kind of got into this of how interdependent features are, so you can kind of go very wide but very shallow, having a bunch of features that are just completely normally unrelated, but you're finding connections, or kind of conspiracy theory stuff versus coming to logical inductions and going deeper and deeper. Does this, with respect, warrant how deep versus how wide you go into connections?
Yeah, so you need to, not only do you need to focus in on the relevant features, you have to focus at the relevant level of analysis as well. So you need to, we'll talk about this quite a bit when we talk about problem solving, so we'll come back to that point. Okay, so just a couple things to keep in mind going forward. Those were kind of, there was a bunch of problems with the theories that we talked about. There's a bunch of conceptual issues, but these two are the ones that I'd like you to kind of keep in mind going forward, because this is part of the continuous argument that runs through the course. Okay? Good with that? Okay, let's switch gears. Let's leave conceptual or categorization and concepts behind and move over to memory as our candidate for a basic cognitive process. So, what's the argument? Why would we think that this is a basic cognitive process? I think there's a fairly straightforward argument, which is just that you need memory to do any of the other cognitive processes. You need to do categorization. You have to remember past events and understand how they relate to your present experience. To do problem solving, obviously you have to be able to remember what the problem was that you're trying to solve, what steps you have available, that kind of thing. So memory seems to underlie everything that we do. That sounds like a good, at least inductive case for it as a basic cognitive process. And we should look at memory because if your theory of cognition contradicts what we know about memory, of course, it's got to be wrong. So, just by way of sort of framing this, there's a whole bunch of kinds of memory. Anybody who's done Psych 101 will know. Sorry, I guess Psych 100 here. There's a whole bunch of different types of memory. We're really just going to focus on long-term memory here. We'll do a little bit of stuff about working memory at the end, but really our topic is long-term memory, not for any deep reason other than we have to focus on something. And so just for the sake of simplicity, we're going to deal with long-term memory. Okay, so as usual, we're going to start from common sense. And we're going to kind of unpack the perhaps assumed common sense assumptions that people have about memory, interrogate them a little, and then come up with a theory that deals with its problems, and then shoot down that theory, and then come up with a new theory, and then show how it's all brought down by the problem of relevance. That's the pattern that we're going to be in for the rest of this first part of the course. Okay, so I take it that the common sense notion of memory is that memory is something like a space. You've got a space in your head where the memories are stored, like a museum of stuff that happened to you. You have a sensory experience. Your brain decides it's important enough to store, so it puts it in the memory space. And then when you try to remember something, there's a little person in your head that goes and runs around and searches through the space to find the thing that you experienced and then brings it back up to consciousness. So where did I put my keys? Bob, the little memory man, runs around your daily experiences and finds that you put them on the couch, raises it up to consciousness. Oh, here we go. Here's your memory of where you put your keys. So memory retrieval on this picture. So memory is a kind of space, and retrieving things from a memory is just going and searching through the space. I think this is a plausible common sense picture for a few reasons. One, a lot of our metaphors use this search through a space. It kind of feels like a search through a space. Like if you if you're trying to remember something, it kind of feels like you're running around different pathways and stuff like that. Notice that our computers work in exactly these terms. Right? That's how your hard drive works. It's a space, it's a physical space that things get put in, and then when you want to retrieve something, it goes to that space and pulls it out and presents it to the processors, right? So this is exactly how computer hard drives work. Less so now, I guess it's getting more abstract as solid state drives come in, but when I was a kid, it was literally like a physical space where bits of metal were polarized. Anyway, so this sounds plausible, right? That sort of sounds normal. And you can use this metaphor. Actually, one of the striking things about this metaphor is that you can actually use it to massively improve your memory. So here's a mnemonic technique, a technique for getting better at remembering things. So it's called the method of loci, and this is used for millennia. People have been doing this. So if you're a Roman orator, sometimes these guys would give speeches that last like 6-8 hours, and they had to have some way of remembering what the speech was how it was supposed to go. So here's how they do it. Remember the show Sherlock? It had like 2 good seasons, and then anyway. Sherlock would do this. So you imagine a space. So you imagine like a garden or a building. So you sit there and you imagine, let's say, a mansion that is your memory palace. And then you imagine a path through that space. Okay, I go in through the front door, I hang a left, I go up the stairs. And then along the path, you imagine objects. So you're a Roman orator, maybe you're talking about how those filthy plebeians are causing trouble again. So you remember the sheaf of wheat over here, that represents agriculture. So you walk in the door and there's a sheaf of wheat on the left. You say, okay, first subject, agriculture. And then all along the path, there's different little objects that remind you of the different topics that you're supposed to work on. This is like ancient Roman PowerPoint. So, and then of course, you associate ideas with this object. And this is a really good technique. This really works. If you want to memorize a long list of things, this is a really powerful technique for doing it. So this, again, just in favor of this metaphor, it's a really good way of training your memory. So that's another reason why we might want to take the spatial metaphor of memory seriously. So it's both like reasonable common sense, and it's a good technique for improving your memory. So good. Now, of course, we got to cause problems for it. So here's an example. So have you ever been to Tokyo? I bet you have an idea really quickly. How did that work? Was that? No, I mean, sorry, yeah. No, I mean, how did you know? Suppose that you haven't. So if I asked you, have you been to Tokyo, and you haven't, how did you know that very quickly? Did you go through all of your memories of all of the places that you've been? Is that how that search went? Seems labor intensive, right? And you did it like that, right? Unless you've been to way, way more places than I've been. I would know immediately if you asked me, have you been to Tokyo? And it wouldn't have to go through, well, to 2018, no, didn't go to Tokyo. 2017, no Tokyo. 2016, like it doesn't seem to be the way that it works. So quickly recalling that something isn't in your memory seems like very hard to explain. If there's a little memory man running around your memory space, it's very unclear how recalling something, that figuring out that something isn't in the space can happen just as quickly as figuring out that something is in the space. I mean, on the spatial metaphor, it's clear how you'd figure out something is in the space. You find it. You find it and you can stop the search. But if you're trying to determine whether something isn't in the space, you have to go through the whole space, don't you? Yeah?
Well, I was going to say, like, with respect to computers, if you're doing like a pointer to something, or even a dictionary, you can check the index.
Right, right.
Well, like, does this even exist, or is there something related to it? If not, just skip it.
Right, right. So I guess you'd have an index of all of the places that you've been?
Well, if you trace your thoughts, you'd be like, okay, well, have I ever gone anywhere? Is Japan on the list? Okay.
So you're proposing that you would have to go through every place that you've been in your life?
Yes, there has to be some level of like searching, even if it is shallow. Like you are pruning and searching. When you ask somebody, it's like, okay, what did you do 5 days ago? And they might not necessarily be able to answer right off the bat every single detail, but if they trace their thoughts out, they could probably make a pretty good generalization of what they did.
I couldn't. I don't. Yeah. Sorry, I get two hands up here. Yeah.
Is there any reason why we have to be looking through all of the things in sequentially in order? Couldn't we just do it like we are doing a lot of stuff at the same time? Maybe it's just looking at all the places we've been at once.
Perhaps. Yeah, that's possible. Yeah. Do you have a...
Something, but
Okay.
for me, it's like I haven't been overseas.
Okay.
I've been to the States.
That's quick then.
multiple places.
Yeah.
But if you ask me, oh, have you been to Wawa, Ontario? I would go through all the places I've been in Ontario and be like, oh, I have been there.
Is that a real place?
Yeah, it is.
Sounds
It's
made
like
up.
the blueberry farms right beside Ontario. And
Okay.
is it Saskatchewan?
Okay. Yeah. Anybody been to Belleville?
Yes.
Ah, I'm sorry to hear that.
But to do that, I had to think like, oh, I've been to Thornhill. And
Yeah.
so I
Yeah.
lost
I grew up in Belleville. It's not a nice place. It's fine. It's fine. It's anyway. Okay. Okay. So this is perhaps solvable. This is a question that might be solvable. Here's another one. Things don't seem to be close. So if it's literally a space, like if it's a static space, things should be close to each other, not in a necessarily transitive way, but a linear way. So can anybody think of a word that rhymes with blue? Glue, shoe, flew. Okay. Now, what's similar to glue? Paste. Okay, so when you think of blue, do you go, that reminds me of paste? That doesn't seem to be how our memory works, right? It's not like because you remember two things are related, that means that a thing that's related to that is like linearly, additively close to the first thing, right? Yeah.
Does it have to be linear though?
If it's literally a space, then yes. So what we're doing now is just adding complexity to our metaphor.
Yeah, I was going to say, if you have like a game or even a space that you navigate, let's say you're doing a min-max algorithm, you're computing positions of, let's say, tic-tac-toe or checkers, you don't have to do a sequential step of each thing. You can just be like, this is the board configuration, branch off to 4 other board configurations, and branch off to those. It's almost more like a tree structure rather than a linear structure where you're going from start to end to each thing.
Okay, so what you're suggesting is something different than a space. If it's a tree structure, then it's not literally a space.
At least in computer science, it's computable. It's like a perfect information game where you can compute either
Okay.
linearly, like everything.
Okay, computable but not a space, yeah? Okay, yeah.
Haven't we already sort of rejected the idea of transitive distance adding from categorization? So shouldn't we, if we're going to insist that memory is a space, shouldn't we be trying to find some other way that we can move around it without having to say, oh, distances don't add, therefore reject it?
Good. Well, I mean, what that tells me is that the stuff from categorization also speaks against this being a simple geometric space. Yeah?
So we need more dimensions.
We might need more dimensions, but even in higher dimensions, this should still be distances should add linearly, right?
Yes, but it could be confusing.
Okay. Okay. So this is just by way of a couple of quick shots across the bow of the search space algorithm. We'll come back to this, but beyond just being a simple metaphor, this started to be developed into a theory of memory, where memory is essentially a series of, so we've gone beyond the simple spatial metaphor now, but memory is kind of a series of boxes in your head. So there's a long-term memory box and a short-term memory box. Within the long-term memory box, there's memories for places I've been. There's memories for foods I've eaten. There's boxes for, and so on and so on and so on. And then the task these theorists thought, this was kind of the 50s, 60s, the task that these theorists thought they faced was just to understand the structure of the boxes in your head, right? So similar to the spatial metaphor, it's similar and different from the spatial metaphor. The spatial metaphor has us imagining literally just like a simple geometric space where things are stored, stable objects are stored in stable positions. So now we've given up the kind of simple geometric space aspect of it, but this model still has stable memories being stored in stable locations. And doing a memory search is still going through the different boxes, trying to find that stable object that you stored there, and then bringing it back to consciousness. Yeah?
Are these models assuming that this space is the same for every single human? Like, it's the same place in all of our brains?
So,
Because then that would be wrong.
right. So in the 50s and 60s, we knew so little about the brain and brain organization. Like we had the rough neuroanatomy that you could see through, like by cutting up brains. But it really wasn't until we started getting fMRIs going that we started seriously connecting. Like at this point in history, in the 50s, 60s, psychology and neurobiology are just radically divorced. So there was no hope that they were going to understand how it's instantiated in the brain. The study was just behavioral and theoretical. So they do behavioral studies and try to build a theory on that. So, I mean, we're in exciting times now where we can actually start talking about where things are in the brain and how they're instantiated in the brain. At this point in history, there was really none of that. Yeah.
I just felt like it's a proven theory, like hippocampus works on our human memory. So if that's not true.
So memory turns out, the hippocampus is incredibly important for memory, but it's certainly not where memory is in the brain. So the emerging, I take it that the emerging consensus on memory is that it's not just simply localizable at any point. So you can't say where memory is in the brain apart from where processing happens. And we'll actually see the beginnings of that theory, we'll talk about it today, how that kind of like, so this has the implication, the assumption that, that there's a processing part of the brain and a memory part of the brain. And so you get stuff in from your senses, and it gets processed in one part of the brain, and if your brain decides it's important, it ships it over to the storage place and puts it in a memory box. And as far as we can tell, like as I understand again, I'm not a neuroanatomist, but as I understand the emerging consensus, processing and memory seem to be much, much more integrated than than this picture makes it sound. Yeah.
What about muscular memory, for example?
I don't.
When you cut off the chicken's head, it's still running.
I don't think that's real.
Real memory?
Well, muscular memory is highly debated. So motor memory is a real type of memory. So you have motor skills, and those are encoded, but they're not just like in the muscles themselves.
I mean, my point is that does your memory necessarily have to reside within your brain, or is it?
Oh, interesting. I'm not sure. I think it's assumed that it's mostly in your brain. The nerves running through your muscles are pretty simple. I mean, the nerves in your stomach are complex and interrelated, but the ones in your arms, I take it that they're just sort of like a two-way wires that go back and forth. There's afferent and efferent nerves, and they just stimulate or don't stimulate. So there's nothing resembling complex processing as far as we can tell going on in the muscle fibers. Again, it's not my area of specialty, so don't take my word on it. Yeah.
With respect to this and higher dimensionality of the geometric model, how can, like, this can be represented with just lots of tensors or matrices and higher dimension vectors. How is that any different than just our geometric model? That you can just both do the same thing, both result in the same thing, or both represent the information the same way?
Well, the spatial metaphor was just a metaphor. And this is they attempted to build this formally. That's the main difference. I don't know that there's, so it depends how seriously you take the notion of a space, and does it have to be like a 3D geometric space?
Well, as I got back to like the search tree thing I mentioned, that is more or less you're thinking of the entire game and all the possible configurations of it as a domain or a space that you then go through to compute whatever the best way you move is. So that could be represented as just a bunch of matrices and vectors of various dimensions going off, and you just search the environment. You pick your algorithm of choice to optimize min-max, gradient descent, whatever. You make the move that you want, but you're still searching the space of like which action or which memory based on my current state should I,
I'm not clear what your question is.
Like, I don't see how this model of this kind of tree branching thing, like from a mathematical standpoint, is different than the geometric model.
Maybe it isn't.
Oh.
Well, it's based on the it's based on the search space metaphor. But again, this is a theory rather than just a metaphor.
Okay.
Yeah? Okay. Okay, so this was supposed to have come out, so this is basically the theoretical version of the search space metaphor. It's just that we're not committed to like a simple geometric space rather than a tensor space or something, yeah? Okay. Okay, so two main assumptions in the kind of memory research pre-1970s or so that I'd like to pick out and that we're going to challenge. One, that you store stable memories, that your memories are stable, just stable objects that stay put. And two, that they're stored in stable locations, right? So that there's some box that you put your memories in, they stay put, they stay still, and their retrieval is just bringing them back. Okay, and here's a study from 1932 that challenges the idea that our memories are stable. I'm not going to show you a whole lot of studies from the 30s. Usually something like this has to be, I mean, it's been confirmed since, but so here's the basic idea. What they did was have people come to the lab, and they'd show them one of the pictures from the middle column. So this middle column is pictures that they actually showed them, and then they give them one of two words along with the picture. So this, they either told them eyeglasses or dumbbell. And then when they had people come back, they waited, I think, a couple weeks, and they had them come back and say, draw what you saw. Draw exactly what you saw. And if you showed them this picture and gave them the word eyeglasses, they would draw something like this. And if you gave them the same picture and said dumbbell, they'd draw something like this. So crescent moon, or letter C, bottle, stirrup. It was the 30s. Stirrups are the things that you put your feet in when you're riding a horse. Yeah? People in the 30s knew what stirrups were. Anyway, so the top one is either diamond in a rectangle or curtains in a window. Okay, so what's happening here? What's happening? What they've done, it seems to me, and it seemed to these people, that they've taken this visual stimulus and found a meaningful association with the word that people gave them. And so they've mashed things together in their memory. What their memory has done is taken the words and the image and kind of compressed them together, put them together in some way, meaningfully integrated the two, so that when you recall the thing, what you're recalling is not simply what you saw, it's more the meaning of what you saw. Imagine your hard drive did this. Imagine your hard drive was meaningfully integrating its contents. So you've got 3/4 of an essay written and you save it, and you come back the next day and your hard drive said, you know what I think that this is really importantly related to is this cat GIF that was on your full desktop. So I put your essay and the cat GIF together. I've mashed them together into a meaningful whole. Like, you don't want it to act like that, right? Because what we want is our hard drives to perfectly accurately reproduce the things that get stored in them. But that doesn't seem like how your memory works. This is one example. I'll show you a bunch of examples of this, of things. Your memory seems to be hungry for meaning, much more than trained up to just reproduce what you're seeing. Your memory seems to be trying to extract the meaning of what you see. Yeah?
I would argue that this has more to do with the fact that there's a lot of ambiguity for each, like the circle with this line in the middle.
Yep.
Has less to do with the fact that you're looking for meaning, but that there's more room for interpretation of what that looks like. So then,
It's two circles and a line. There's no ambiguity. In that image?
no, but when they tell you eyeglasses or dumbbells, there's more room for how you interpret that picture.
It's two circles and a line. It's a very simple image. The image itself is unambiguous, completely unambiguous. Two circles, one line, right? One line connecting the middle of those two circles. That's the most definite stimulus you can imagine. There's nothing unclear about the visual stimulus. But when you combine it with ideas, then people reproduce something different, right? Both of these groups produce something different than this is a completely unambiguous figure. Especially this one. The other, The other ones, it's like, oh, how curvy was the sea? You know, like beehive hat, I don't even know. But like here, this is just like a super clear image that people didn't reproduce exactly. They reproduced something that meant something to them. Huh? Yeah?
I didn't see there is any reason like this graph contradicts our previous theory that memory is not stable. Memory is like stored in stable locations. I didn't
So this isn't stable locations, this is unstable objects of memory.
But like,
So
but like assume like if you say like stable location is in our brain or like, so the location is where, like because.
So we're not talking, this is not about the location where it's stored, it's about the object being stored.
The theory had two parts, right? Stable objects in stable locations?
Yeah.
So right now we're
We're doing-
arguing against stable objects.
The stability of the objects. And
Presumably stable locations will come later.
I can't remember if it does. Oh, so, okay, so the point here is that the assumption that you're tempted to make in the naive view of memory is that what you're remembering is just what comes in your eyeballs, right? So when I remember something, what happens is I get a visual stimulus, and then that stimulus, the exact match of that stimulus is being stored. And this just seems to show that that's just not right. It's not what you're seeing that gets stored, it's what it means to you. Yeah?
How does this play into, like, one of the readings gave the example of children's drawings of, these are drawings of kids from the countryside, and, you know, people came up with their own explanations of why these drawings differed with respect to the prior information given of, okay, the child was from the city, the child's from the countryside, these children have developmental issues or whatever, or were in no trouble, I think they used the word. And people came up to their own conclusions of like, oh, this is how I'm going to categorize this based on this prior information that you've told me. And they kind of cooked up their own explanations of why. So how does this relate to that? If I tell you something prior beforehand, I'm going to change the way or what you're looking for, or how you're going to reason about it when you're classifying it, or recalling it, should I say?
Well, that doesn't seem like a memory task to me, so I'm not sure it's strictly related.
But you're still providing, if I ask you something and I give you a bunch of information prior that's going to change the lens at which you try to go and retrieve that information from, isn't that similar to me going to that person checking or telling them, it's like, okay, this kid was from the city, that's why this drawing looks this way. Like,
No, maybe. Our relation doesn't jump. I don't even, which reading was that from? I don't.
It was the second one. It was the one with like theories and I believe it was prototype and classical theory.
Huh.
Critique of that.
I do not remember that. So I don't feel like I can comment since I don't remember that bit of the reading. Okay.
This one.
That's not helpful from back here. Okay. Okay.
The concepts and conceptual structure.
Okay, yeah, I don't remember that anecdote, so I don't think I can comment. Okay. So the point of this, and this is not the only study that I'm going to cite for you. This is a whole bunch of stuff. Since the 1930s, we have continued to explore this idea. In slogan form, and this slogan is a bit too reductive, but just to get it in slogan form, memory is reconstructive, not reproductive. So a videotape is reproductive. I'm recording this lecture right now. When I play it back later, it will be, some interference aside, just exactly what happened. And that's not how our memory works. All of the research that we've done on it suggests that's just not how our memory works most of the time. So this slogan is a little too reductive because it's not the case that you're never able to reproduce an exact stimulus. But overwhelmingly, what your memory does is reconstruct what happens on the basis of what it meant to you. And this is like, I find this kind of disturbing, but it's also very heartening. in another way. So it's disturbing for any of you who have ever had an argument with a significant other or an important person in your life, and you're arguing about exactly what happened. You're both remembering it based on what it meant to you, not what happened. So she's like, you called me a jerk. You're like, no, I asked you to do the dishes, right? She's like, well, it felt like you called me a jerk. Like, that seems to be overwhelmingly what human memory is like. It's a terrible disadvantage in some ways that we don't have, and I'll give you a bunch of studies and examples to try to make the case today, that we don't get access to the particular non-significant details of what happened. So if it wasn't significant in the sense that it meant something to you, you lose access to that. And that makes us bad at remembering in a lot of ways. In a lot of ways, our memories are very poor. What they're good at and what they should be good at, and here's the slightly less depressing part, is extracting the meaning from your world. And that's kind of what you want. So it's not kind of, it's exactly what you want. I take it that there are two possible explanations for how we got here. One is that God made us, and one is that we evolved. For either of those explanations, you can always ask, well, why are we like this, right? Why would we be made with memories that mangle together stimulus so that they mean something to us, but we don't remember what actually happened? I'm on the evolution side of this, so I'll give you the evolution story. Evolution cares a lot more about whether you're able to deal with the future than whether you're able to accurately remember the past. So if you're in a situation where, so imagine a mind, and people do, some humans are like this, where they have just hyper-specific and accurate memories going back their entire life. Yeah? Cool, okay. So some people consider this a gift. Some people consider it a terrible curse because they are burdened with memory, in a sense. They are unable to sort of so when something bad happens to me or when I do something stupid, that kind of gets filtered out over time. As time passes, it sort of loses significance and salience for me, so that I don't have to, I did so many awkward things in high school, so many, but I don't remember them anymore. That means I don't have to deal with them anymore, right? Because that's not important for me now to live my life, right? If something important as in meaningful happens to me, then I will remember it. I will be able to generalize from my memories. I'll be able to extract lessons from them. I prefer my way. I prefer the kind of spotty memory that extracts meaningful lessons rather than having an extensive record of every silly, awkward thing I did in my adolescence. So if evolution is how we got here, evolution just has to be barely good enough to keep you alive, right? That's all evolution's optimizing for. Did you survive, and did your close relatives pass on their DNA? That's all it cares about. So getting the details of an argument you had 10 years ago right isn't on that list of things that evolution cares about. It cares about whether you're able to extract meaningful patterns, generalize, figure out what's important. Yeah?
Why do we then sometimes hold on to absolutely idiotic memories? I can remember as a kid playing Game Boy, and, Pokemon Red, whatever,
Sure.
trying to duplicate some kind of thing. It's that is totally not relevant. I haven't
Well,
used that in 10 plus years.
So notice that there's two strategies here. There's the generalizing for meaning, and then there's the capturing the details. And neither of us are pure one or the other. So it is sometimes important to remember the details of things, right? So if you're I buried my food here, you need to remember that. It's not just enough to be I remember burying food, I don't know. You need to remember the specifics. So we've got these two strategies in competition, and some people are extreme in one direction or the other. And I'm just trying to make the case for the generalizing meaning extracting strategy as an important one as well.
Does initial exposure to, let's say, the same event build that memory up in terms of importance that you retain seen it, so
I don't know.
if you do something over and over and over again, it's going to be kind of burnt into your skull and you'll remember it years later in life, even if it's not relevant to you.
I don't think so, because there's lots of routines that you forget. Like, I don't remember, I walked the same route to school every day of elementary school, and I don't remember the houses on that route, despite hundreds and hundreds, maybe thousands of
There's a
exposures.
form of kind of typicality with respect to this, then how often do I have to recall this memory, or how often does this memory?
It doesn't seem to be a function of just exposure. Yeah. Yeah.
Wouldn't it still be reproductive, just in a different sense? Like, rather than you're reproducing the entire scene, you're just reproducing the meaning and then reconstructing the rest of it?
You could speak that way if you wanted.
Okay.
I'm trying to make a distinction here between reproductive and reconstructive, so if you take the meaning of those, then I'm happy. You can talk, words mean anything you want to use them for. So if you want to argue that there is a sense in which you're reproducing the meaning, here reconstructive means you're reconstructing according to the meaning, and reproductive as in reproducing the details. That's the distinction I'm trying to make. Yeah? Okay. Yeah, I mean, these are arbitrary ways of splitting it up, so.
Because then couldn't you just say that rather memory is just a meaning store instead of a stimulus?
I suppose you could. I don't like that as much as a slogan, though.
Yeah.
That's the point of slogans, right? To condense the idea down to a point where it's no longer barely recognizable, but easy to remember.
Yeah, but I'm just saying that it seems kind of misleading then, because then memory is still reproductive. If it's a
Okay, so if what we mean by reproductive is reproducing the details, then no, it's not.
no, but you.
So that's what I mean by reproductive.
Mhm. Yeah, but then your memory, if it's just the meaning, right? If you look at it from that perspective, then you're still reproducing the meaning. You're not reconstructing the meaning.
You're not even reproducing the meaning, because the meaning is filtered through your current values and interests. So you're still, even if we're just focusing on meaning, you're still reconstructing it. The way that you'll remember your past will be colored substantially. And I'll show you a study today that shows you that actually you can change the way that you reconstruct by changing your goals and interests in the present. Yeah? Okay. Okay, so I gave you the slogan form of this. Let's actually do some empirical studies to put some flesh on these bones. So here's a fun one, just talking about the unstable objects of memory. This is basically just going to be telling you that your memory is terrible. Not terrible. It does the job that evolution needs it to have done, but it's terrible if you imagine your memory being like a video recorder, then it does very poorly. So here's one from Loftus and Zanni. Eyewitness testimony, the influence of wording a question from 1975. So subjects were shown video of a car crash. The video was 2 minutes long or so. Car crash takes up about 4 seconds, so there's not a lot of time to think about this. And there was either, so in two different groups, there was either a broken headlight in the video or there wasn't. And in each of those two subgroups, there was two subgroups. One of the subgroups was asked, did you see the broken headlight? And another was asked, did you see a broken headlight? And regardless, in both groups, so one had a broken headlight in it and one didn't. In both of those groups, if you asked people, did you see the broken headlight? They're like, yeah, I think I did. And if you asked, did you see a broken headlight? People were far less confident that they saw one. So regardless if there was a broken headlight in the video, by asking them the question, did you see the broken headlight? People became convinced, and they were sincerely convinced that they saw one. So the framing of the question, and this is, I mean, think about eyewitness testimony. This is not idle speculation. People's lives can be saved or destroyed on the basis of people thinking that they remember what happened. And so people have, since the 70s, people have taken this into account when you're doing kind of like police interviewing people or interviewing people on the stand, to try not to be like this, to try to not ask questions like, did you see the broken headlight? Because the way that the question is posed to you has a profound impact on what you bring out. And you can't really explain that with the spatial metaphor or this sort of memory as a box, right? So this is in direct contradiction to the idea that your memories are just a set of boxes where you store past stimuli and then you go into the box and pull out the stimulus, right? If that's true, this should not happen. Yeah?
What if the memory is stored in like multiple boxes, and depending on like the question asked, like it changes the boxes that are being pulled to answer a question?
But there's no box in which the people who didn't see a broken headlight saw a broken headlight. So there's literally, they saw a video in which there was no broken headlight. So there can't have been a memory box where the stimulus of a broken headlight went in, right? If memory is literally just like a video recorder, so if it's reproductive in the way that video and audio recordings are reproductive, you can only get out what you put in. I mean, you get a slightly crummier version out, like you get a degraded version of it, but you can only get out things that you put in. Whereas here, people are pulling out things that were not put in. They're saying, and then they'll have, the weird part is, they will be convinced that they have a memory of a broken headlight. It's not just that they're like, I don't know. So the options were yes, no, or I don't know. So every one of these people was given the I don't know option, and far, far more of them were convinced that there was a broken headlight when they were asked did you see the broken headlight? It's creepy, right? This should creep you out a little. Question? No?
I was just going to say, part of it is everyone does remember a broken headlight. Everyone has seen a broken headlight.
Okay, so somewhere in your memory, but not, the question was a broken headlight in that video that I just showed you.
No.
Yeah, so
no.
they might have retrieved some other memory maybe or something like that. But that's just sort of like, that's equally creepy that what they've done, and if that's right, then what they've done is reconstructive. That is, they've taken a bit from the video they just saw and a video thing that they saw like on the street 10 years ago, and they've put them together and said, yes, I saw that broken headlight. Yeah?
Is it reconstructive, or kind of with respect to that question, is it more continuous, where our memories kind of blur into one another?
Well, that's, to be reconstructive is just to put pieces together. So that's what I mean by reconstructive.
Oh, okay.
Yeah.
Wouldn't it still have to be partially reproductive though? Because you wouldn't be
Yeah.
able to say like, did you see the plane crash in the middle of the road? If it was completely reconstructive, then you could.
That's right. So you're absolutely right. And again, this is why it's just a slogan. It doesn't tell you this whole story. Because of course, if you ask them, did you see the like bright green alien ship landing? They'd be like, no. And if you ask them, did you see a car crash? They would all accurately say yes. So it's not the case that we never remember what happened. And you can, like going back to this thing, it's not like they're just drawing something utterly random, right? And it's not like they're drawing something unrelated to the stimulus. These drawings bear substantial, I hope you agree, these drawings bear substantial structural similarity to the original stimulus. They're not just making stuff up out of nowhere, right? What they've done, however, is meaningfully integrate the parts of the stimulus, the word and the picture, into one thing and distorted, they've produced something similar but clearly not identical to the original stimulus. So if you want to say that that's partly reproductive and partly reconstructive, I'm happy with that. Yeah? So the real story is that our memory is a mix of reconstruction, reproduction, kind of put together in a way that maximizes the meaningfulness of what you're dealing with. Yeah? Okay, so this should be, again, this should be disturbing to you. So here's our reproduction of that study with a slight twist on it. Despite what you might have been told when you were introduced to the scientific method, studies that reproduce past results are actually very rare because you don't get grants for doing studies somebody else has done. If you go to you're a scientist and you go to your department and say, I'd like a big grant to do a study somebody else already did, they would say no, right? So you always have to put a little twist on it. The twist that these people put on it was that one of the groups was hypnotized. And I'm happy to report to you that hypnosis is a real thing in the sense that it's a real psychological state that people can be put into with real measurable psychological effects. And when a group of people was hypnotized, the effect size was even larger. This is from the late 70s, when hypnosis was actually a socially important question, because people were operating on a kind of Freudian model of memory. So Freud has this model of memory that goes like this. Some things you can remember. Some things, however, you can't remember. They are repressed because they are either too traumatic or socially taboo, and therefore your unconscious filters them out. It keeps them repressed, and through therapy or whatever, you can bring these repressed memories out. And he's got a kind of search space model of memory, right? There's a part that's above water and a part that's below water. And if you could figure out a way to get at this repressed material, you can find out what happened. So people were hypnotizing people in court cases, they were hypnotizing children, and there was what was called the satanic panic. So children, okay, you laugh now, but it's a grim, grim story. So children were being hypnotized, and they would recall under hypnosis being abducted and ritually abused by Satan worshipers. And people were going to jail for this. And it turns out that wasn't a real thing. That wasn't, I mean, maybe it happened once somewhere in the world, but like a whole bunch of children were, because they were asking, they would put them under, like, do you remember when they took you? Right? Just like, do you remember the headlight? Do you remember when they took you? Yeah. Do you remember when they did the ritual? Yeah. Right? So, and their confidence, so under these conditions, the confidence of people's memories goes way, way up. Right? So the people who were hypnotized in this group, they're reproducing just the headlight thing. They're confident, they do both, did you see it, and how confident did you see it? The effect got larger and their confidence went through the roof. Oh yeah, for sure I saw that headlight. For sure I saw it. So essentially what was the basic problem here is that the Freudian model of memory is not right. It's not just that you have like a deep underground well of traumatic repressed memories that are just stable. They're just like exact copies of what happened to you, stably preserved in an inaccessible location. Because that's not how memory works in general. Not that you can't have repressed memories, but all memories have this reproductive aspect or reconstructive aspect to them. And putting people under hypnosis seems to make them more subject to this kind of effect. Yeah?
Is it true that if you don't believe in the hypnosis, it won't?
I've heard this. I don't know a ton about hypnosis. I've heard that you have to be kind of a willing participant in it for it to work. So, yeah.
I don't know if you guys watch like Good Mythical Morning.
Good Mythical Morning?
Yeah, it's like Rhett and Wink, and it's like a show on YouTube. But I've been watching it for a while, and they did an episode where they underwent like hypnosis.
Yep.
And Wink is someone who's like willing and able, and so it worked. He really didn't like tomatoes, and it worked on him. He ate tomatoes. He got furious when he couldn't have a pizza completely made of tomatoes. It worked. And he had no idea it had happened until like a day later.
Yep.
He was still undergoing the effect of he could eat tomatoes now, because from before he would just vomit.
Yeah.
And then after like a week had passed, he got over that. So now he like still doesn't eat them. Right?
Yep.
But the mind reset. But for Rhett, what had happened was he still was able to undergo hypnosis, and you're completely right. It is being like you have to like tell yourself like, okay, sure, this could work.
Yep.
But he was the person who said like hypnosis is not a thing, like that's a crock of crap. Like he did not believe it, but it still worked on him. So
Okay. So n equals 1, hypnosis works even if you don't believe it. Yeah. Let's not get way into hypnosis, but yeah.
Is there any kind of measure of, I guess, rigidity to memories? Like, can a certain memory be more or less vulnerable to kind of mutating?
So there's I don't know a ton about this. Like I don't know of any specific study that measures rigidity of memories. There's flashbulb memories. So this class of memories that people seem to have around particularly significant events where they'll recall a whole bunch of details about a certain moment. And those seem to be reasonably accurate. So if you have a flashbulb memory, it's like a separate class of memories. If you have a flashbulb memory, it tends to stay stable over long periods. Yeah.
Is it possible to synthesize an entirely new experience, like not related to any kind of memory that you would have before? Is this implant an idea?
Inception style. So everything I've read about this suggests that because what your memory is doing is building something that's meaningful to you, that it's always got to be based on something that's meaningful to you. Like it's always got to be based on parts that you've got already in your psyche somewhere. So, like,
say I'm a greedy person, and very naive, money is meaningful to me, and you would plant some kind of memory into my head where I'm either losing money or something. Is that possible?
I don't know. I've never heard of that being done. I have no empirical basis to say yay or nay here, so I don't want to speculate. Okay. Okay, so we're talking about the context of retrieval now. That is, contrary to the spatial metaphor, the context in which you retrieve a memory seems to make a difference to what gets retrieved. If that's if the spatial metaphor is true and you just got a bunch of memory boxes that you put stimuli in and it stays still when you put it there, it shouldn't matter what situation you're in when you're retrieving it, what gets retrieved. But nonetheless, it seems to. So let's try to show that. So here's Sachs, not Oliver Sacks, but Jacqueline Sachs. So this is, I find this all to be a little weird. This is genuinely disturbing. So you give the subject some sentences to read, and then you ask if they had just read a given sentence. And if they had just read it, if they had just, like, you give them the sentence, ask them if they saw that sentence, they're really accurate about telling you whether they saw that sentence. But if you let them go on for a couple more sentences, reading a couple more sentences, then they can no longer tell you whether they saw that exact sentence or not. So compare these two sentences. He sent a letter about it to Galileo, the great Italian scientist, versus he sent Galileo, the great Italian scientist, a letter about it. Now, they would show them the top sentence and then ask them whether they'd seen the bottom sentence, and they couldn't tell you. And we're talking about like moments later. So they read two more sentences and then they read the bottom sentence. Yeah?
Isn't this just an effect of having like short-term versus long-term memory? Like they operate in different ways. Like short-term memory is more accurate, long-term is more like less accurate but more storage? Sorry, I remember learning about this in cognitive psychology.
Okay.
So totally okay, not in scope for right now.
Yeah, so that could be an important factor here, like whether it's for short or long-term memory. Yeah. Yeah.
Or could this be related to primacy and recency effects?
So primacy and recency effects are whether something's at the beginning of a list or whether you saw it recently. But like,
They couldn't remember the last sentence. So they
okay.
couldn't remember the first sentence better.
But it's not that they. So compare these. What they couldn't remember, and what I'd like you to take out of this is the distinction between form and content. So, of these three sentences, so these first two that I just showed you, and the bottom one has a different content to it, right? So, if people could tell the difference between 1, 2, and 3, so Galileo, the great Italian scientist, sent him a letter about it. Big difference between you sending Galileo a letter and Galileo sending you a letter, right? Those are in content different. So people could, if they'd read this 2 sentences ago, they could tell you whether they read 2 or 3. What they couldn't tell you is whether they'd read 1 or 2. So 1 and 2 share the same content. They mean the same thing, right? So if what memory is latching onto is the meaning of what happens to you, what we should expect is that you'll draw the sense, the significance of the sentence, but kind of ditch the surface form. So notice how the, 1 and 2 have different surface forms, but they mean the same thing. Whereas 3 has a different meaning. And what people could get, what they would retain, and we're talking literally like 10 seconds later, they'd lost the form. They'd only retained the meaning. So again, something to keep in mind, you're arguing with your significant other. If what you're arguing about is the form of what was said, probably you don't remember. You probably don't remember that seconds after it happened. Yeah?
Do we lump salience in with meaning when we talk about the structure of a sentence like these?
Okay, so do we lump salience in with meaning? Okay, so meaning can mean a bunch of different things. Meaning can mean the significance or the salience or the relevance. So what's the meaning of life? People are not typically asking what does the word life mean? What they're asking is, what's the point of all this? So the point of it is one sense of meaning. There's another of semantic meaning. So words and sentences have semantic meaning. That is the things that they specify and the way that they specify them. So these sentences signify, the meaning of these sentences is just that a letter went from one person to another. That's separate from the significance or relevance of it. So here we're talking about the content as in the semantic meaning, the kind of significant, the linguistic content of it. Not really but, okay, and here's why I'm flapping around about this question. It's not obvious to me that you can separate those two senses of meaning. So if you really want to know what a sentence means in the semantic sense, you might have to have a grasp of what it means in the relevant sense. Do you know what I mean? Yeah, so these are questions that it's unclear that they are cleanly separable of the different senses of meaning. Yeah.
I mean, kind of on that point, wouldn't it, if we're filtering or processing stimuli
Yeah.
to better remember something, then wouldn't we be forgetting the unnecessary details of remembering, I guess the important whole or the content of it. So the first, second, and third letter, sentence, the first two mean the same thing. So you've already derived the meaning. There's no need to really remember where the word "the" is, unless unless you were going to be tested out which one.
Right.
Which sentence came up, in which case I think you would maybe be more likely to remember. The third sentence means something different. So, and then again,
I think you got it.
Created a third or fourth sentence that was similar to the meaning of the third sentence. You would probably not remember each one.
Good. Yeah.
But could that be seen as almost pre-processing memory? So maybe it's not even about recall. When you see something, you see stimuli, it's kind of the base of where you're gonna, that's the base content that is required to remember something, right? Much like the accident. The color of the car is not significant, but so long as it's not an airplane. You're remembering two cars crashing.
So hold that thought, because we're gonna explore the idea that there are levels of processing, and that the level at which you process profoundly influences both what gets stored and what gets retrieved. So it'll be significant to both of those processes. So we'll get there very shortly. Yeah.
Do you know if results like this are consistent in different languages?
I do not. Yeah. Typically, so almost all of these studies are done on what are called weird subjects. That is, Western, educated, industrialized, rich, democratic countries. Almost exclusively on undergraduate and grad students in the psychology department. That's the easiest subject pool to get. They just round up a bunch of people and give them extra course credit. So this is a serious question, and especially I think this was from the 70s, especially back in the 70s, it was almost universally assumed that if you tested weird psychology students, that would generalize to all of humanity. And that it didn't matter, culturally specific questions didn't matter much. You didn't need to do populations from different areas or different linguistic cultural groups. They have begun the process of trying to A, test that, and B, mitigate its effects, but we're just at the beginning of that process. So if it's anything before the 80s, it's an extremely safe assumption that they were just testing, like, a couple of studies today are from the University of Toronto, so they would just round up U of T grad students and put them in a lab, and that's how they got their subject pool. Yeah. Yeah?
Kind of respect the language thing. Can you take the reductionist approach of just super simple language, and does this also apply to different forms of input? So will I...
Sorry, I didn't understand the first part.
Say, instead of like English, I just went to just, I don't know, Morse code or something, a really simple language.
Well, Morse code encodes characters in regular languages.
Say binary.
Okay.
Well, if a person could understand binary, you know, just read it, understand it, will they construct different meaning from that?
I really don't want to speculate about what a study that hasn't been done would say.
The other question I have is like, does your meaning change with respect to whether you're seeing something, whether you memorize something verbal, kind of like how our categorization with, you know, verbal versus, I guess, visual categorization places?
Well, we've seen so far today, we've seen a couple linguistic studies and one visual study. So I would say it works at least across those two modalities.
Does it seem to mutate or affect one more than the other?
It's really hard to compare effect sizes. Yeah. Yeah.
Okay, so just for context, I speak both English and French.
Okay.
And I know a plural of other languages.
Uh-huh.
The point is that if you translate all 3 sentences in French, I don't know if anybody else in the room speaks French. I'm assuming. Okay. But if you were to read like the 3rd sentence versus the 2nd or the 3rd in a book, you definitely would not. You wouldn't pinpoint which word you read, like which sentence you read. So it's working the same way in French as it does in English. But the way that you formulate your sentence, like if you were given the first sentence, like he sent a letter about it to Galileo, the great Italian scientist, and then afterwards they said, okay, was the sentence number 1 or number 2? Like, or the teacher had asked you what is the sentence, or like what was the sentence trying to say, you would say your meaning. You wouldn't be able to verbatim repeat what the word was, because when you're speaking back, you have to change, like you have to reply in the form that your memory works, rather than in the form that you would write a book.
I find that very plausible. I find it very
I'm not
plausible.
saying that it's completely true, but I'm just saying like in the circumstances.
I would be surprised if this was something very English language specific, but I'm unaware of any study that confirms that. So just for that. Yeah.
So there's a language called the Micmac language.
Uh-huh.
And it places emphasis, or to structure a sentence, you put the most important things at the start of the sentence.
Clever.
And then you work your way down.
Uh-huh.
So 2 sentences can contain identical information, like, you know, I saw a moose on a hill.
Yeah.
And that could be restructured as moose on a hill I saw, which doesn't really make sense in English, but just like grammatically.
Yeah. Yeah.
But so one sentence places strong emphasis on you saw a moose, and one sentence places strong emphasis on it was on a hill. So you can imagine people that are fluent in this language, that are used to speaking it day to day, you could give them sentences that even have different meaning, but they have sort of a long lead up of the same information in the same relevance order. But then at the end, maybe somebody sent Galileo a letter versus Galileo sent somebody a letter, and they might not be able to distinguish those 2 sentences, whereas an English speaker would say, actually, no, these are very different.
This is my dubious face. I'm very dubious that they would be unable to distinguish he sent me a letter versus I sent him a letter.
They would be able to distinguish that.
Okay, let's not make up studies and then decide what they say. That's not how science works. Let's stick to what we've got. As feeble and thin as our evidence is, none of this is evidence you should absolutely take to the bank and be like, it is established. We should absolutely be sticking to the evidence available. Yeah.
It's easy to define memory as something that's influenced by the physical world, but like what about something like dreams and stuff? Do they not like get any meaning? Something like that, because I think that shapes how
So I would call, I think dreams fit within the framework that we've been doing so far. So a dream is a kind of stimulus. If we want to say stimulus, like maybe that you're not getting through your sense organs, but that is happening in your brain, that's a kind of stimulus. So it's a kind of conscious experience. It's a kind of thing that happens to you. So probably you get the same effects with dreams. Yeah.
Do you think that so like what happens in real life versus like a stimulus from a dream, do you think those two things like intermingle in a sense? Like if I were to try and recall, like if I've seen something happen, like maybe I'm recalling something that I've not experienced but have seen.
I've had that experience where it was unclear whether something was in a dream or not. Yeah, and it certainly affects your day, but yeah. Okay. So, yeah.
Yeah, to respond about the foreign language, basically what you're saying then is that two sentences which have a different form would have a different content in that language, but the same content in English. So they're still, you're basically saying that they would distinguish between them because of the content still.
Maybe not necessarily even content, just structure. Like, so
Okay.
the first two have the same content and the third one has different content.
Yeah.
But you can imagine the other language, maybe the second two have very similar structure. The first one has different structure, so they might distinguish between them that way.
Okay, I think we got to move on. We've gotten too deep into speculating about. Do you have a quick one?
I have a question about the dream.
Oh, okay. I feel like we're drifting way off topic, but
Well, I mean, it has to do with memory.
okay.
Okay, is it true that like memory is like certain memories that are important are like dissipated from the brain through dreams?
So okay, so this is very much on topic. So dreams seem to be something else. There's a few different things that happen during sleep. One of them seems to be memory consolidation and forgetting. So here's something that you probably don't think is super important, but is actually vitally important for your mental health and well-being, forgetting almost everything that happens to you. And that's during one phase of sleep, that seems to be what happens, that your brain is sorting out, here are some important events from my day. Everything else gets shoved off to the side. We'll talk later in the course about a speculative hypothesis about what dreams are for. And it seems to be more that dreams are for exploring possibility spaces. So dreams are where, I mean, this is a speculative hypothesis, but the idea is that dreams are where your brain kind of opens up new possibilities, new ways of seeing for itself that are necessary to come to your world with a more kind of like creative and open field. But memory consolidation seems to be a different part of sleep. So yeah, sleep is vitally important for you. And one of the vitally important things that it does, because we're all in the finitary predicament, you have to forget almost everything that happens to you. And sleep is where that happens. Hi. Just gonna go ahead and close this door. This is like the fourth visitor we've gotten today. Okay. Yeah.
Then if it were for people like with perfect memories, like during their sleep, does it still happen the same?
I don't believe that anybody has perfect memory.
Or if it's like a very good memory that
So, very good. I'm not even. So, the question is, what do you mean by very good memory? Because even.
you said that during sleep, it's important that our brain will use it to forget things.
Yeah.
So then if someone has like a very, very good memory that, like before you were talking about how many people, they might have difficulty actually forgetting things.
So people have. There's a wide difference in what people remember, but there's nobody that remembers everything by any stretch of the imagination. So you can. I watched. In preparation for this lecture, I watched a BBC lecture on or documentary on people who have this like excessive recollection for their personal memory. So there are some people who have really detailed autobiographical memories. On February 17th, 2007, I woke up at 8 a.m. and the weather was like this and it was a Tuesday and so on and so on. But if you give those people standard memory tests, they do average, or sometimes below average. So they have autobiographical memories, get locked into their brain and are accessible forever, But that doesn't mean that they can just sort of flip through a book and remember every word in it. That doesn't mean that they do any better on working memory or that kind of tests. So it seems to be that some people have very specifically tuned memories for a certain type of memory, and it's by no means that they just remember everything. So they're sorting for, okay, my brain thinks autobiographical memory is super important, so when they go to sleep, they forget, you know, you're not going to remember every scratch on every tile, you're not going to remember every car that goes by you or the license plates on all of them. You're going to dump all of that, but you're going to keep, your brain thinks autobiographical memory is super important, so it's going to keep that. Yeah, just given the amount of information available to your brain, it has to be the case that you dump almost all of it. There's just no way to keep it all. Okay. Okay, yeah.
I don't know how relevant this is, but so like sleep wouldn't be the only time. Like how would you define forgetting? Because like there's, if you ask me, like I promise I was awake, but if you asked me 2 minutes ago, like what did you say 2 minutes ago? I wouldn't be able to say, right? So there's like certain situations where you forget details while you're awake. Would that be considered forgetting, or is the information still there and like while you're sleeping it has to be physically there?
So unclear. It's unclear. I don't think that we know enough about memory to really say specifically what's going on. Yeah. So quick, because I do think we should move on. Okay, sorry, yeah. This is fascinating, but we should, before we exhaust everybody's attentional stores, we should get through the material as well. Yeah, okay. So on this confidence thing, and this has to do with some of the questions we've been dealing with about, you know, can you just remember stuff that never happened to you? And this kind of suggests to me that actually what you're doing is reconstructing things that actually did happen to you. Okay, so here's a study. It's a study by Bransford and Franks, The Abstraction of Linguistic Ideas. Okay, so what they did is give people a bunch of sentences. And they gave sentences like the rock hit the hut, or the tiny hut was by the river, or the rock hit the tiny hut by the river. Okay, so they're presenting them a bunch of sentences. Does everybody know what a proposition is? A proposition. So a simple proposition is just the attribution of a property to an object. That's the simplest form of truth-bearing sentence that you can have. So the rock hit the hut. That's like a one proposition sentence. You can have more than one proposition in a sentence. So the tiny hut was by the river. So that contains at least the proposition, the hut is tiny and the hut is by the river, right? Okay, so they would give people a bunch of simple sentences, and then they'd give them a complex sentence like the rock rolled down the mountain and hit the tiny hut by the river. Sometimes, so this graph shows us a bunch of things. Let's go through it a little bit at a time. So some groups had seen, so they show them a proposition like and the question is, have you seen this sentence before? This is the question. And in some groups, they had seen the sentence before, and in some groups they hadn't. They'd just seen sentences 1 through 3. So you've seen both groups have seen all of the parts of this sentence. Some of them had actually seen the target sentence. Now, we've got 2 lines on this graph, old sentence and new sentence. I'm sorry you can probably barely see those, but for our purposes, fortunately, they basically overlap. So the old sentence line is people who had seen the sentence before, and the new sentence line is people who hadn't seen the sentence before. And the vertical axis is their confidence rating. So how confident are you that you've seen this sentence before? And you can see those lines basically overlap. So here's the first thing to notice about this graph. Whether you'd seen the sentence before or not didn't actually affect how confident you are in whether you'd seen the sentence before. That doesn't seem to be a factor. So people who had never seen the sentence before were exactly as confident as people who had seen the sentence before that they're seeing it again. Okay, so that's kind of weird. Here's another fact about this. So this horizontal axis is how many propositions are in the sentence. Are there 4 propositions, 3, 2, or 1? Okay, so suppose we're in the 4s. Let's suppose number 4 has 4 propositions in it. If you're seeing number 4 and you've seen 1, 2, 3 already, you are super confident that you've seen 4 before because it puts together a bunch of your prior experience. 4 integrates a whole bunch of stuff that you've seen in the past. And so your confidence in whether you've seen it before seems to be correlated with how much information it's integrating for you, not whether you've actually experienced it or not. Again, this should creep you out a little. And then if it integrates less information, people's confidence goes down, regardless of whether they've actually seen it. Notice the confidence ratings are pretty close on all of these metrics. So it goes from -5 to +5. -5 is I've never seen this before. +5 is I've definitely seen it before. So at the 1s, there's a little bit of variation, but for 2, 3, and 4, people are pretty much exactly as confident whether they've seen it or not. And the thing that defines their confidence is actually just how much information it's integrating for you. You can do this with just dot patterns. So you show people a series of dot patterns, just patterns of dots in a little box, right? And you can do the mathematical average. So if you show people a series of dot patterns, different dot patterns, and then show them the mathematical average of those dot patterns, they will tell you that their highest confidence is in the mathematical average, regardless of whether they've seen it before or not. Right? So you can produce a very clear average of like where the dots are positioned on the page. If you show them the average, even if they've never seen it before, they're like, oh yeah, for sure I'm sure I've seen that one before. Right? Just regardless of whether they've seen it before or not. So, again, something to keep in mind when you're arguing with your loved ones about what actually happened. Your confidence in your memories is really not correlated with whether they're accurate or not. Your confidence in your memories is based on how much they integrate meaningfully your experiences. Yeah?
Why is that? Why the fact that there are more presuppositions in a sentence predicts that the level of confidence is higher?
So,
and it's like, if you think logically, it should be the opposite, because if it has only one presupposition, then you're like, oh, it's pretty simple. It's one idea and it's simple. I can indicate it whether I've seen it or not. But the more, why is it contralogical? Is there an explanation?
Well, the explanation is in terms of the story I told you about what you want your memory to be doing for you. So if what you want your memory to do is not just to record the world like a videotape, but rather to extract meaningful generalizations and patterns from it, then what you're doing when you say, I've definitely seen number 4 before, is actually tracking how meaningful, in the sense of how integrative it is of your past experiences. So you had a bunch of past experiences. Number 4 is the best at integrating them together, just like the statistical average of the dot patterns is the best at integrating your past experiences together into a meaningful whole. And if that's what you want your memory to do for you, then that's a good thing for it to be tracking, right? And it's not that these things always come apart. Sometimes the meaningful integration is an accurate representation of what happened. It's just that if you have to choose, your brain cares more about meaning than it does about accuracy. And why biochemically? I have no idea. So, yeah?
Couldn't it be argued that this is also kind of like a complexity of the memory that's being recalled? So number 4 is more complex than the other one. So it's made of more pieces versus the other ones have, 1 or 2 pieces or 1 piece per one. So whether I'm conscious of it, I'm doing a check of like how many pieces do I need to make to assert that, yes, I've seen
So, two things here. That doesn't explain the dot patterns because the dot patterns are all equally complex. And it doesn't, like if you showed people questions 1, 2, 3, and then gave them a really complex sentence that had nothing to do with what they saw before, they wouldn't be confident that they'd seen it before, right? It's not just that any complex sentence is like, oh yeah, I've definitely seen that one before. It's that it's both got a lot of parts and it's a meaningful integration of what happened to you before.
So is this more like a summation of incomplete information that I previously encountered to assert that new information I decided whether
Well, it's not that, so all of the propositions in sentence 4 are contained in sentences 1, 2, 3.
Yeah.
So there's no incompleteness of the information. You've got all of the information needed to assert 4 in 1, 2, 3. And that's why people are so confident that they've seen it before.
What if I showed, let's say, the people only the first 2 sentences and then asked them if they had seen 4? Will they answer differently then versus people who had seen the first 2?
Again, I'm not gonna say what would happen in a study that wasn't run.
Okay.
That's just not we should not be. Don't tempt me. I'm a philosopher. I love saying things off the top of my head, and I have to not do that.
That's a measure. Like
Well, again, it's a very reasonable question to which I don't know the answer. That's the serious answer to your question. Yeah. Okay. So worrying, right? I don't know. I find this all very worrying because I put a lot of stock on thinking that I know what happened in the past and not just what it meant to me. Rather, I think that I know exactly what happened in a lot of cases. And my confidence, what this tells me is my confidence in my memories is uncorrelated to their accuracy. It's correlated to how significant that integration of memory, of past experience is. Yeah. So, okay, so we've done some work on, let's call that enough work on kind of complexifying or problematizing the spatial metaphor of memory, the idea that you've got stable entities that you can recall in accurate ways. So the way in which something is recalled, the context in which something is recalled seems to matter. The way that it's experienced seems to matter. So maybe we should try another theory. So let's all talk briefly about this and we'll do a break. So here's the reading for today, Craik and Lockhart, a really classic paper in the memory research, specifically taking aim against this view of like memory as a series of boxes that you just store stuff in. And their framework is what's called levels of processing. So they're trying to argue basically that you're going to remember things it's not just passive storage. Their basic idea is that the act of remembering and the act of processing are inseparable in important ways. That is, processing and memory are running on the same hardware. We'll see a version of this. When we do AI, we'll see a version of this with neural nets. With neural networks, there is no separation between the memory of the system and the processing of the system. Those are just the same systems. Unlike standard computers where there's a hard drive that does, and RAM that does the storage, and then there's the CPU that does the processing. I'm sorry, I know it's more complicated than that, but there really is a physical separation between the storagey bits and the processing bits, whereas in a neural network, that's just not true. And these guys are well before the neural network sort of revolution, but they're making the same basic case that processing and memory are tightly integrated. They are not separate. We're talking about the levels of processing approach. So let's look at some evidence for this. So here's some evidence that you can use to argue for the levels of processing approach. Give people the following questions and see which answers they remember best. So, is table in capital letters? Okay. Does market rhyme with weight? And would friend fit in the sentence, he met a blank on the street? Okay, so you give people a series of this style of questions and have them think about them. And what they found was people's recall, so if you ask them later, did you see the word table? Their recall is much, much worse than if you ask them a question like, did you and ask them, did you see the word market? And it's best if you ask them a question like C, and then did you see the word friend? So they're much more likely, given these three styles of question, to remember the words said, presented in C than they are than B, and again, they'll remember B better than A. Now, why would that be the case? So the levels of processing approach suggests that what your memory is an interactive, like your memory is a kind of like replay of the processing that you did. So the processing you have to do to deal with question A is pretty surfacey, right? Like if it had been in Spanish, if instead of table it had been a Spanish word, even if you don't speak Spanish, you could have answered the question. Is it in capital letters or it isn't? You're just looking at the letters. Now, question B asks you to process a little bit more deeply, let's say, metaphorically, because you have to at least understand the sound of the word, right? To answer question 1, you don't even have to get the sound of the word to go through your head. Question 2, you have to at least have the sound of the word. And question 3, you have to have the meaning of the word. You have to know what the word friend means to answer that question. So these questions are designed to invoke different levels or depths of processing. Yeah? And what they found was the deeper the processing that they induced, the better people remember things. So this is evidence, it's supposed to be evidence for the interconnection of processing with memory retrieval. Yeah? So it's not just you have processing and then once it's done, you ship it off to the memory box. The idea is that the processing and the memory are integrated in important ways. So, Craik and Tolving argue that people have much better memory when they're prompted to process deeply, and furthermore, the intention to process seems to have little to no relation to whether you are, the intention to remember seems to have little or no effect on recollection. So if you prompt study, if you say to people, okay, you're going to have to remember these words later, then they perform about as well as people who you just tricked and said, here's a bunch of questions, try to answer them. So the original one was, this is a reading comprehension task. And you're blasting through these questions thinking, yeah, I'm the best at reading comprehension. I'm getting all of these. I'm comprehending all of these questions. And then at the end they say, actually, it was secretly a memory task. And then ask them these questions. If you do that, people perform about the same as if you tell them ahead of time, this is a memory test. I'm going to ask you to remember these later. Try to remember them. Which, I mean, if you've ever, and you should really keep this in mind when you're studying for this and other courses. So, what's the worst way to study? The worst way to study is to read your notes over and over again and make this scrunched up face where you're like, remember, try to remember. That does nothing for you. That's the worst way to study because that's surface level processing. You're tired, you're not really thinking hard, you're not trying to reflect on what you're reading, your just eyes are moving across and you're exerting the attempt to remember. And all of the evidence suggests that that does not help you remember. What does help you remember? Thinking hard about the content. Yeah?
Is the method of loci like surface level then, or is that somehow a deeper?
So, what the method of loci does is, and most mnemonics work this way. What the method of loci does is give you a way of integrating the information that you're trying to remember. So it's all of it is integrated into the space, and the sheaf of wheat on the ground is integrated with your thoughts on agriculture. So the method of loci is precisely a way of trying to integrate information. If you're trying to remember somebody's name, you come up with a little mnemonic. You say, Jimmy rhymes with, nothing rhymes with Jimmy. I don't know, what, Himmy? yeah, like if you want to remember somebody's name, you come up with things you can associate with the names to give your brain something to integrate. So the integration seems to be what helps us remember things. Yeah, so, yeah. Okay, and notice, just take a second to reflect on how poorly your education has been designed with respect to these well-understood facts about memory, where what you're asked to do is to reproduce the sentences that are presented to you. That's mostly what your education has consisted of, being asked to reproduce sentences. Hopefully some of you are I take it in STEM subjects, there's a little more to it because you're given a problem set. In a problem set, you have to employ skills and you're engaging with it in a substantially deeper way. But your humanities education has probably been set up like this where you're just like, I'm going to tell you some facts, and you're going to tell them back to me. Which, by the way, you've got a test coming up in June 6th, and what I'm going to do is the following. I'm going to give you very broad topics, and you're going to tell me what you know about them. And the way that I'm going to be marking them is to test for understanding and integration of the knowledge. So please know that I've marked thousands of tests and assignments from undergrads. It is very obvious to me when somebody's saying my sentences back to me, and the difference between that and somebody who's struggled to understand and integrate and like get what's going on. That's not a subtle difference from where I'm standing at this point. So what I'm looking for, what I'm going to be looking for, what I'm going to mark you on is how well did you integrate the information and try to understand the information with which you've been presented. With any luck, that will help you remember it after this class is over, rather than just memorizing a set of sentences so that you can spit them back to me. Yeah?
Would we be given practice problems? Because we haven't really done any of those types of things yet.
Yeah, I think that's reasonable. Yeah, so I'll come up with some practice questions. They're going to be really broad topics. So I'll do something like, it's just going to be literally like a list of major ideas in the course. So I'll be like levels of processing. And then what you're going to do is define for me the levels of processing thing, tell me what it's a reaction to, tell me what some problems are with it, tell me how it's related to something in categorization or problem solving. So building these connections between the different ideas, tell me what the debates are about it and that kind of thing. So yeah, I will give you some like sample question and answers before the test. Yeah.
Do we need to know who said what, or is it enough to just know what was said?
If you remember who said what, that's great. I am super bad at that, so I'm not going to require that you do it. It's a good fact to have, but it's not a requirement to get a good mark. Yeah. Sorry.
Like sentence structure, like our writing?
Not on the test, but yes on the essays.
Okay,
Yeah. So very different standards for tests and essays because on the test you're sweating and nervous and you're trying to get it done as fast as possible, whereas the essays you're cultivating this piece as a piece of writing. So yeah, I don't care too much about I want sentences, but I don't care much beyond that. Okay, so yeah. Okay, let's back to memory, yeah? So another very interesting effect called the generation effect. Having people generate a word makes them much more likely to remember. So if you just present people a word, they'll remember it okay. If you have them generate the word, they'll remember it much better. So what's a synonym for rapid that begins with the letter F? Fast. Okay, so now for the rest of your life, you're going to remember fast. No, not really. But like, if I just said to you the word fast, then you would remember it at a much lower rate than if you produce it yourself. And I take it that wasn't like that's like a crossword puzzle level thinking. Like this is not humongously difficult processing, but just having done that processing greatly enhances recall. So again, the argument for the integration of processing and recall, that these are not separate things. Here's a really neat one. I love this. This is one of my favorite studies in this whole thing. So processing and recall being integrated. So they had subjects read stories about two boys playing at home. It's two kids, they're off from school, they're at home, they're playing. One group was asked to read it from the perspective of somebody getting ready to rob the house. So imagine you're a burglar, you're trying to plan out a robbery. Another group was asked to read it from the perspective of a potential home buyer. Okay? And then subjects were given some distractor tasks. They, fill out this form, do whatever, so that it has to be in long-term memory rather than short-term memory. And then they were asked to recall the story again. So they really okay, so write out everything you can remember, every little detail. They really emphasize, tell me every little bit and piece from the story that you recall, big, small, everything. Okay, got it all. They wrote out everything that they could remember. And then they said, okay, for the home buyer group, they said, okay, now imagine you're trying to rob the place. And people went, oh yeah, lots of big windows on the ground floor. Ah, okay. So by switching perspectives after they'd heard the story, so they're given one perspective. Before they hear the story, they're given one perspective. And they remember everything they can from it. And afterwards, they're given a new perspective to think about the story from, and new stuff becomes accessible to memory. So you can reprocess the same information from a different perspective. Neat, right? Again, heaping misery on the just boxes version of memory, that you've got stable memories in stable locations. Okay. So we're going to shift a little bit and do some... Okay, so that's levels of processing. It's good stuff. Interesting. It seems to be a theoretical advance. We're going to shift now to some stuff that's hard to explain from within the levels of processing approach. Not knockdown refutations by any means, but stuff that seems to go beyond the machinery that I just laid out. So, and this is going to get us tangled up in all that relevant stuff again. Okay. Encoding specificity. The context of learning seems to have a significant... No, sorry, we're not in problems yet. We're still in stuff within the levels of processing approach. So the context of learning seems to have a significant impact on how memories are stored. So the example that's usually given at this point in the course, I cannot find a citation for this, but it makes a good story, so let's go with it. Underwater welding. Underwater welding, super expensive to train people how to do underwater welding. You have to have the welding stuff, you need a scuba gear, you need either a big tank or the ocean or something like that. So it's very costly to train people. So the way they train people was to have them learn welding above water and then put them in the water. And what they found was they get underwater and forget how to weld. They're in a new context and their learning from before just doesn't transfer over. So, and this seems to be, I'll tell you from my experience, this is absolutely the case. Last 2 semesters I was teaching logic. So I was freshening up on how to do deductions. Oh yeah, so I'm in my living room, I'm comfortable, I'm in my pajamas, no problem, deductions, killing it, I can do deductions. And then I stand up in front of a room of 300 people and try to do it on a Wacom tablet. I'm like, oh my God, I can't do deductions anymore. It's logically equivalent tasks, literally the same logical tasks. It would be the same deductions I'd done the day before. I'd practiced the deduction at home. And in that new context where my adrenaline is obviously way higher and I'm in a different headspace, I lost the ability to do these deductions. I had to relearn how to do deductions in front of a crowd. So this encoding specificity stuff, it seems like aspects, almost clearly irrelevant aspects of your environment are important for recall. So again, if while you're studying, you have headaches and take a bunch of aspirin, when you're doing the test, you'll do not a huge amount better, but statistically significantly better if you take aspirin. You should, when you're studying for a test, use the same pen every time, and then use that pen on the test. Yeah?
So presumably we should study and write the test in this room.
Yeah, but we're not going to do that. Sorry. I think the effects are not large enough to outweigh the fact that our tests are going to be in the middle of the summer, and this room will probably be super hot. So what I've done is put in a request for the exam center. Also, this is a real cheatable kind of room, right? Like you're kind of looking, you have very easy access to what's going on in the person in front of you. So despite the advantages of encoding specificity, we're not going to do that. What you can do is imagine the space that you're going to write the test in. So has everybody been in the exam center? Yeah, okay, so we're in one of the rooms on, assuming that the request goes through, I'm still waiting, but we're in one of the rooms on the 3rd floor. It's like a 100-person room. It's air conditioned, there's big nice desks. So while you're studying, you can imagine being in that room. I mean, much more important is that your studying has the right basic format, which is what you should do is try to guess what questions I'll ask you and practice writing out answers for them. Because the context of training is related to the context of performance, right? Your training should match your performance. So your performance on those tests is going to be explaining what concepts are and how they're related to other concepts. So what you should do is try to guess what I'm going to ask you. It's going to be the main ideas from the course, and write out answers for those things. And if you've done that, then you'll do much better on the test. Probably what you're going to do, what most of you are going to do, is read over your notes over and over again. And you're going to read over the notes where you said, this is the worst way to study. Yeah. That's what I did when I took this course. There. Okay. So, some problems for encoding specificity. So, problems for levels of processing. Hard to define levels. Really unclear. They've never really got super clear, and you'll have to either take my word on it or look at the literature yourself. They never really define what they mean by levels. And in some sense, they tried to do a kind of circular definition where the more you remembered it, the more it must have been a deep level of processing. But then they defined levels of processing. So they defined depth in terms of remembering and remembering in terms of depth. So there's a bit of a circularity in like, what are these levels? How many are there? What do you mean by level? None of those were super clear. And furthermore, both the context of retrieval and the context of storing things seems to be important. So if levels of processing is right, it's just the context in which you've encoded it that matters. It shouldn't be the context in which you've tried to retrieve it. But actually, that does seem to matter. So let me try to show you that now. So here's another study where they took the same task that I just showed you, the same thing, where they're showing them these sentences that ask questions and then trying to get them to recall it. However, now people were asked questions like, do you remember a word that rhymes with weight? So they were asked questions that matched the way in which the original word was processed. So did you see a word in capital letters that said table? And people would remember that because it's asking a question that fits the way it was originally processed. Right? So does market rhyme with weight? And you ask them, do you remember a word that rhymes with weight? And they'd say, no, but I remember market. Right? So just matching the way that you're trying to retrieve. So if it's encoded in one way, then it's easier to retrieve if you ask a question that asks for the same kind of encoding, for the same kind of processing. So the level of processing does matter, but retrieving it is also a matter of trying to retrieve it in the right way. Does that make sense? I feel like I didn't. Getting a little. We've been at this a while. I'm getting a bit loopy. Okay. So it's not just that the way that it's stored matters. Right? So they would, in the original one, people remembered A much, much more poorly than they remembered B or C. And they remembered B more poorly than C. But if you ask the right question, people will remember B better than C. So if you ask them a question that's framed in the same way in which they originally encoded it, then they'll be perfectly able to remember stuff. So this is a quite different result than the one that I showed you a minute ago, where it's just the way you encoded it that predicts how well you remember it. Here, it's the fit between encoding and recollection that matters. Right? So if you encode things in one way, you want to retrieve it in that way. And you'll be good at retrieving it in the way that you encoded it, not just if you encoded it deeply, then you remember it across all different contexts. Yeah?
Can you encode something multiple ways to kind of increase your flexibility and ability to retrieve it?
So, what maybe we want is transfer appropriate processing. Maybe depth of processing can be understood in terms of the multi-aptness for transfer across contexts. So when you've acquired something really deeply, maybe that means that you can recall it across different modes of recall, right? So, and I don't know, again, this is my just drawing off purely anecdotal experience. This is my experience of anything that I've learned really, really deeply comes up a lot for me. Right? You think about it like across many different contexts. You're like, oh yeah, this is like that thing that I really learned the heck out of. So it could, here's just a proposal. Maybe the depth of processing corresponds to how, like instead of just memorizing the sentences that I'm saying and saying them back to me, maybe the depth to which you process something is correlated rather to how much you process it in a way that you could deploy it in several different contexts. Remember this stuff about scientific theories that we did way back in the first lecture, where I'm like, you know what you want your scientific theories to do is to be multi-apt, to be usable across a whole bunch of different contexts. Well, maybe our memories are like that too. Maybe what we want out of our memories, the thing that makes them well memorized, is that you can use them all over the place. That is, you can recall them across contexts. But that's really hard. That's super hard. Like, consider the and this is where relevance comes into this memory stuff. Consider what an incredibly challenging job your brain is facing when it's trying to encode things in the way that you're going to need them later. Sometimes you'll know what context you're going to need the information that you're taking in, you're going to use it, and you know what context you're going to use it in. Sometimes you don't, however. Think about a first date. So you're on a first date, the person is telling you things about their life, and it's not clear to you, they're telling you an anecdote about their family. Now, maybe this is both the first and the last date, and the only possible reason you're going to need that story about their family is to maybe do a humorous callback later in the date. Maybe you're going to hang out for a bunch of dates, and you want to know something about their personality, and that's why you need to know about their family. Maybe you're going to get married and raise a family together, and the story that she told you about how her mom is crazy is actually a key to understanding the family dynamics that you will reproduce between each other as you raise your own family. Huh? Okay, so you don't know, it's the first date. You have no idea what's going to happen. You have no idea in very many contexts in your life how you're going to need to use the information that you're taking in, right? So the multi-aptness is required of you, but you don't know how you're going to use information later, right? So somehow, some way, your brain has to take in information in a way that cuts out the irrelevant stuff without really knowing what's going to be relevant. It's really incredibly difficult task that you're facing. You need to somehow pick out the important stuff without knowing what your life is going to be like in 10 years. Yeah.
Does not link back to the monkey problem of kind of like, I need information to know what is relevant in the new information that I'm getting at? Like,
So in some sense. So it leads, I think mostly it leads back to the relevance problem. So it's not necessarily a homunculus if you can figure out a way. If you can figure out a way of like saying how we work out what's going to be important, and of course we fail at this all the time, right? You don't always pick out the relevant information. But if we could have some account of how we manage to do as well as we do, that would be a way of figuring out this problem of like, how is it your brain decides to store not only which information, but which encodings of the information do you need to collect? And yeah, I mean, the worry is, of course, that there's going to be, I haven't given you any attempts to formalize this, so there's no homunculi problems for formalizations, so we haven't even got a theory of this yet. So
like back to the example dating. So say you got some person who's never dated before.
Huh?
They're just awful at speaking to people. They find the girl of their dreams first date, and then they start bringing up all the things like, oh yeah, I live with my parents.
That's
I
a
don't do
nightmare.
my own laundry. I can't cook. Basically, it's totally uninteresting, a failure of a human being.
Oh.
They don't like know necessarily not to bring that up. They need that information somehow. So yeah, you don't sell yourself.
Right. Right. So yeah, so we very often fail to encode things or to know what's going to be relevant. That's just a human condition. Yeah. Yeah. Yeah.
So if, for example, if you don't know in the future that you're gonna get married or whatever, but then when you sleep, then you forget. But then in the future, if you happen to remember some fact in the first day, does that mean like it's just sitting, your brain decided that it might be important?
Yeah, it must be somehow. So because you can remember something that you forgot, there's got to be a bunch of stuff in there that's not directly accessible to just like you trying to consciously access your memory. So there must be like, and you know, hopefully you've all had the experience of seeing a photo of yourself from a long time ago, and you're like, oh yeah. So you can spark memories that are clearly still in there. So there's got to be layers of unconscious memory in there that are not accessible to you as just a purely conscious will of like, I want to remember what my 15th year was like or something like that. So there's got to be layers of memory for that to be a possible thing that happens. And I'm sure we've all had that experience where you're like, oh yeah, I remember that. Yeah, so.
But then how do we know if we're actually forgetting something or if we just didn't get the right,
The retrieval cue. Yeah. I don't know. I don't think we understand memory well enough to answer that question in any kind of definitive way. Yeah.
Well, when you look at like something like extinction when it comes to unlearning like a reinforced behavior.
Yeah.
It's not that you forget the reinforced behavior, but you learn how to inhibit the response to that behavior.
Yep.
Couldn't memory work in a similar way where you don't actually ever forget, you just inhibit the recollection or the pathway to recall a particular event? Because the thing is, if you inhibit a particular response and then the stimuli like shows up again, then the response just like comes back, right? So if you're conditioned to respond to like a bell, for example,
Yep.
And then you through hundreds of trials learn to inhibit that response, but then you hear that bell again, the response comes back. Couldn't memory work the same way that you inhibit the recall of it until an event occurs that brings up that memory, and then everything goes back.
So I guess the question is would that mean that you're storing every single fact that passes through your experience? That it's all in there somehow? I find that the only thing is I find it biologically implausible that there's that much room in our brains.
Well, like, let's imagine like there's no limit to like long-term memory, right? Like no known limit.
No known limit, but there's.
It's hard to imagine that there could not be a limit to long-term memory.
Yeah.
Right. So
Yeah.
if we're moving towards what like evidence like suggests, right? And I'm not claiming to understand that, but if we're drawing a parallel from conditioned to non-conditioned responses, like what would stop us from putting that into like memory, comparing that to memory, like using that as a model to understand that. Because it solves a lot of the problems that we have, right? So like the issue of, you know, you have that first date, a topic comes up, and you forget it for, you know, 15 years, and then an event occurs, and suddenly you remember what you conceivably have forgotten.
So that sometimes happens, but I think it's probably more common that we just never recall stuff. So there's just huge amounts of your life that you don't recall, right?
But I mean, could it be that you just don't, you never store that information to begin with? So when you are in an environment, you have to be very specific as to what you are focusing on. Like you have a limited amount of attention, a limited amount of focus.
Mm-hmm.
So whatever you can transfer into your short-term memory, right, will eventually move into your long-term memory. Those are the things that you'll remember.
I mean, okay, so what
that you don't focus on won't ever be there.
Again, we're kind of speculating here. What we're doing is saying maybe it works like that, and maybe it does. I'm just unaware of any evidence. Yes, I see your hand. Yes.
I was going to say, this might feel like if you can inhibit something, would that also then imply that you have to inhibit almost near infinite amount of things to not pay attention to them, to not memorize it? Because you're having to keep track someplace of like, this is not important, so you're having to inhibit it.
Not in the model you just presented, where you're only storing stuff that's made it through the filter of working memory. So that's not a near infinite. So there's a fair, your working memory is actually we're about to talk about working memory. So your working memory is actually a very narrow conduit. So that's a kind of like tractable amount of information. So you'd only have to inhibit things that made it through that fairly narrow filter. Let's talk about working memory. So for example, do you feel that you could easily memorize this list of letters? If I change this slide quickly, would you be like, oh yeah, I can produce that no problem? Yeah? Yeah? Okay, how'd you do that? You just remember it. Wow. Okay. For me, that's too much. Yeah. You can chunk it. You can chunk it. So now do you think you could remember that? What's that? Ah, good. So F bin Rashia is like you've chunked it into phonemes, at least for yourself. Right. So chunking is a thing that we do to our world. We break the world up into sort of like manageable pieces, into meaningful wholes. I can't remember. I mean, when I was a kid, you had to remember phone numbers, and I'd have to take it one bit at a time. You remember the first 3 numbers, and then there used to only be 7 numbers. Anyway, so we chunk our world. This is what we do in order to pass the like. So your working memory, the general consensus is that you can hold roughly, on average, 7 plus or minus 2 like things. If it's a number or a letter, little meaningful units. Something like 7 on average. Some people have better, some people have worse working memory. I think I have like probably below average working memory, frankly. But you can get more stuff into your working memory by creating these larger meaningful units. So now this is only 3 things you have to remember. The 3 organizations that know your address and your credit card history. So one question, once again, why are we like this? Why have we got such terrible working memory? Chimps have better working memory than us, by the way. If you give a chimp a task where they'll flash 10 numbers on the screen and ask it to tell it what order they were in, the chimp can do it. We can't. So they're actually better at this. At this specific task, they're better than we are. So why? Why is our working memory so bad? And one potential way of explaining this is that it's acting as a kind of, well, one potential explanation is that we're poorly designed. And we are in many ways poorly designed. Like really, really. Like the food hole is the same hole as the air hole. Did you ever notice that? If I was making us, I would have done it very differently. So there's all kinds of examples of just really bad design that if you were doing it from scratch, you'd figure out something better. Or like in unassisted childbirth, here's a horrifying statistic, medically unassisted childbirth, in 1/4 of cases, either the mother or the child dies. Boy, I would have designed that. Starting from scratch, boy, I would have done that differently. But it's just barely enough to keep the species going. The problem is our enormously large heads, which is an enormous biological advantage. So that's why we have that unfortunate situation. But so maybe our working memory is similarly just a really bad design. Or here's another explanation. Maybe it acts as a kind of relevance filter. That is, there's a really complex process somehow working in our brains to only allow a very few number of things into working memory, right? You're only allowing conscious access to a few small number of things to kind of filter out the as William James said, the bloomin' buzzin' confusion. And it seems to be deeply related to consciousness. So your working, things can only get into, so you can remember things that you weren't conscious of. The fact of the matter is that you're taking in information that doesn't pass through your consciousness, but you can only get things into working memory via consciousness. Like you've got to be conscious of it first, and then it gets into working memory. And we'll explore later in the course the idea that basically what consciousness does is try to sort out what's relevant from what's irrelevant. It's a kind of elaborate relevance filter. So maybe it's the case that working memory is so narrow precisely to act as a relevance filter. Yeah?
How can we remember dreams?
Well, you're conscious during dreaming. It's a conscious experience. Yep. So consciousness is a term of art. Okay, so here's a thing that Mary Potter suggests. Here's a 3-stage model of memory. Stage 1, huge amounts of stuff is retrieved from memory, most of which is not relevant. Stage 2, there's a selection process, filtering for relevance. And then stage 3, the memory is passed to consciousness. Oh. Okay, so, I mean, that sounds plausible. Somehow our brain is solving this immensely difficult problem of A, storing the relevant stuff, and B, recalling the relevant stuff, such that you can solve the problems in your life, right? The whole thing, the theme of today's lecture has been that your memory is not tuned up to remember exactly what happened. Your memory is tuned up to help you solve the problems that you face. That's what it does. And it's perfectly happy most of the time to sacrifice accuracy if it can give you a better chance at solving your problems. For our purposes, considering this as an attempt to analyze, formalize, and mechanize cognition, stage 2 is a disaster, right? It could be true that that's what's happening, but once again, we've got this unformalized notion of relevance lurking in the background. And it's probably fair if you're starting to feel like, oh no, it happened again. This keeps happening. These problems seem to be interconnected in this really deep way. To get to the root of memory, it seems like we have to understand problem solving, right? Because if our memory is tuned up to help us solve problems, then in order to understand memory, you have to understand problem solving. And to understand problem solving, you're probably going to have to understand categorization. But we saw with the microtheory, to understand categorization, you probably have to understand problem solving. And to understand problem solving, you're undoubtedly going to have to understand memory. So all of these problems seem to require the solution to the other problems in order to solve them. That's what we might call the interconnection problem. Yeah?
Couldn't you understand cognition as like the results of like having those 3 components?
Well,
so, like you can't have cognition without all 3 of those
yep.
parts, much in the same way as like a car would work.
Absolutely. Yeah. So this is the interconnection problem is not supposed to be insoluble. Actually, so we're gonna see in the problem. We'll start on problem solving on Thursday. We're gonna start to see that we can maybe make some progress on this and maybe get into some deep cognitive processes that maybe underlie all three of these. That's rather different than when I took this course. So in 2001, I took this course, and the moral of the course was, therefore, cognition can never be analyzed. That was the conclusion. The whole running thesis of the course was, we will never understand cognition. It's forever beyond our ken. In the intervening, seems like eons, the Professor Verveake, who kind of designed this course, thinking has evolved considerably. We've had some scientific advances. We've had some philosophical advances with stuff like dynamical systems theory. So now that's not the moral of the course. The moral of the course now is something like relevance is crucial to cognition. So relevance seems to be underlying both problems that we've seen so far, categorization and memory. We're going to see it again in problem solving. So maybe understanding relevance is the way to understand cognition. Our ability to figure out what's relevant is going to be the core to understanding cognition, and I'll make some tentative suggestions about how maybe we can do that so that it doesn't end on this dismal note of give up, we're never going to get it. Yeah. Okay, that's probably enough. Let's call it a day, and we'll do problem solving next time.